Hey, Mr. Simonini here. This video is about graphing in all three forms of quadratics. This actually covers homework D, E, and F. Well, I'm actually going to separate this into three separate videos, but this whole document that I have in Notability right now covers the problems that you're going to see these next 3 days for our e-learning. Anyways, the first thing that you have to be able to answer is questions like the vertex, max or min, domain range, how many solutions, and y-intercept. So I want to clear that up before I start graphing. So if you look here, I already have a graph. It's a parabola opening down with a vertex. Again, my vertex is the top, the maximum point in that case. My vertex is at the point at the very top. In that case, it's 5, 4. It is a max. Now remember, maximum happens whenever a parabola opens down. So it's always a max when it opens down. Domain is always negative infinity to positive infinity. Just a reminder about range, when it opens down, remember it's negative infinity to your top y. So in this case, it'd be negative infinity to 4, not 5, because 4 is my y for my vertex. And that's my top y. How many solutions are there? Now, whenever you see the word solutions, I'm going to probably say this a billion times in videos. Solutions are x-intercepts. So it's asking you, so just know whenever you see the word solutions for a quadratic, solutions are x-intercepts. So in this case, it's just saying, hey, how many x-intercepts are there? In that case, there are 2 x-intercepts, or in other words, 2 solutions. Now, if I ask you for what the solutions are, in that case, it would be 3 and 7. My y-intercept, there's always a y-intercept. Always a y-intercept. And for quadratics, what you need to do is you need to plug x equals 0 into an equation if I ever give you one. Or just look at the graph. Now, a lot of times the y-intercept is going to be off the graph, meaning it's going to be bigger than 10 or smaller than negative 10. But as you can see in this case, I made it a really small number. I'm not going to put 21 tick marks there. So if you look here, my y-intercept will be, I'm going to put it in a different color, will be 0, negative 21. It's always an ordered pair. It's always going to be 0, y, wherever it intersects the y-axis, the graph. So just to be clear, that is the y-intercept. Now let me move on to the next part. What happens if a parabola opens up? So if you look here, my vertex in this example, if you look, it's right here on the x-axis. So my vertex is going to be negative 4, 0. Is this a max or min? Now when it opens up, meaning it goes up, it's always going to be a min. Domain is always negative infinity to positive infinity. Nothing new there. My range, just a reminder, when it opens up, is going to be my bottom y to infinity. So in this case, it's my bottom y to infinity. So my range, in this case, be careful, it's not negative 4. It'd be 0 to infinity. And then how many solutions are there? In this case, how many x-intercepts are there? Well, there's one x-intercept. And in that case, it's going to be negative 4. So there's one solution. And then the y-intercept is where does it cross the y-axis? Again, it will always have a y-intercept. In that case, it's going to be 0, 16. Now I'm actually going to do one graph in vertex form, and then I'm going to stop this video and make another video for standard form and factored form. So graphing in vertex form. So whenever you have the graph in vertex form, this is the example. So just to be clear here, vertex form is right here. So this is something that's in vertex form. You have parentheses squared and then plus or minus some number after it. So in this case, remember you take the opposite what's inside for x, which is going to be 3 in this case because the opposite of negative 3 is 3. And then whatever number is outside, in this case is going to be 2. And then you're going to put it in your graph. So I'm going to put 3, 2 here. Now this might be a part where it's a little bit different than what we've done in class because you don't have your yellow calculator, so we have to adjust a little bit. Remember, what we're using is www.desmos.com to graph these. So if we look here, one thing that you have to do is you have to be able to get numbers. You want 2 points above the vertex and 2 points below the vertex. And what you need to do is you need to put your x's in. So what are two numbers before 3? Well, that would be 2 and 1. What are two numbers after 3? Well, that would be 4 and 5. So what you can do then is go to decimals.com. I already have it graphed for you and actually was playing with it a little bit. Let me try to go back. Let me delete it and then let me rewrite it. So let's say if y equals negative 2, x minus 3 squared plus 2. I think that's what was our equation, right? Just double checking. Looks good. So there's my graph. Now, in order to get the table, what you do is you hit that gear, and then you hit table, and then you have to manually put your x's in. So we wanted 3. We wanted two numbers before it, right before it, so it'd be 2, 1. I always want to increase my x's by 1. So after 3 will be 4, and then after 4 will be 5. As you can see, I get the points, my other points for my table that I need. So if you look here, I'm going to come back now. So I got negative 6, 0, and then 0 and negative 6 here. Now I'm going to go ahead and graph it. So when I graph it, I got 3, 2. It's always, I want like at least 5 points. Try to be consistent with always getting me 5 points whenever you graph these. 3, 4, 4, 0, 1, negative 6, 1, 2, 3, 4, 5, 6, and then 5, negative 6 will be right there. I'm going to go ahead and graph it and then answer the questions. Okay, so is this a max or min? Well, it's opening down, so that's going to be a max. What's my domain? Negative infinity to positive infinity. What's my range? Well, it's opening down, so my range in this question will be negative infinity to positive 2, because it's negative infinity to my top y. How many solutions are there? Remember, these are x-intercepts. Now my graph is a little bit off here. I did a bad job drawing it. Let me try to draw it again. Try to hit these points. It's hard to graph on Notability, especially a quadratic. Okay, it's a little bit better. But anyways, if you look here, my solutions are my x-intercepts. So in that case, there are 2 solutions in that case. So there are 2 solutions. And then what is my y-intercept? So again, my y-intercept is whenever x is 0. So something that you can do, there's a lot of things you can do different here. So y equals negative 2, 0 minus 3 squared plus 2. You can plug 2 in for x and then plug it in your calculator and get an answer. Or you can go back to decimals. Decimals.com can help you. You can look in your table. You see I have 5 highlighted right now. I can change that to any number I want. And I want to see, hey, when I plug in 0, what do I get? Well, I get 0, negative 16. Another thing you can do, understand you can move the graph around with your fingers. If you look here, it also gives me the y-intercept. You look to see where it crosses the y-axis. So there's many different ways you can find it. There will always be a y-intercept, just to be clear. In this case, if you do plug 0 in, you get negative 16. So my y-intercept is going to be 0, negative 16. Now, it doesn't show up on the graph, but understand that does make sense. So this would be, what, 11, 12, 13, 14, 15, so 16. This graph continues and hits it right there. Okay, so just to be clear, that's where it's going to hit. Anyways, that's how you graph in Vertex form. I'm going to make another video about standard form and another video about factored form. So questions 2, 3, and 4. Again, these questions are going to help you out for the next 3 days. Thanks.